Hi everyone, welcome to Mr. Wagid's math class again. We already talked about similar figures, and we know similar figures, they are objects, they have the same shape but different sizes, and those are two examples of that. But the most important thing about similar figures, just like this Eiffel Tower, if I want to make a replica of this Eiffel Tower for them to be similar, just like this one, all sides has to be proportional. Otherwise, it won't be similar. Or even making a keychain of the Eiffel Tower. All sides has to be proportional. So now let's review what we already know about similar figures. How can you decide if those two shapes or two figures are similar? Only if corresponding dimensions are proportional. So set up your ratio, because equal ratios means a proportion. So set up your ratio big to small. Big diameter to the small diameter and the big height to the small height. Substitute the numbers. Make sure the diameter is 10 centimeter over 4 centimeter. Does it equal 15 centimeter over 6 centimeter for the radius? Yes, 10 divided by 4 is 2.5. 15 divided by 6 is 2.5. So the ratios are equal. It is proportional. What does that 2.5 mean? 2.5 means the big cylinder is 2.5 times bigger than the small cylinder, which we already discussed before in different lessons about dilation with a scale factor. So the scale factor is 2.5. It's an enlargement by a scale factor of 2.5. What if I did the other way around? What if I compared the small cylinder to the big cylinder? I have to set up the ratio again, but this time I am setting up the ratio small to big with each corresponding dimension, the diameter and the height. Substitute the numbers. 4 divided by 10, does it equal 6 divided by 15? If I divide those and they both are equal, which means the side lengths are proportional. What does that 0.4 mean? It means that the small cylinder is 0.4 times smaller than the big cylinder. Also, it means it's a reduction by a scale factor of 0.4. We also learned how to find the missing side length of similar figures. Here's an example. The figures are similar, find the missing dimension. Set up your ratio first because they are proportional, they are similar. It doesn't matter how you set up your ratio, small to big or big to small, it doesn't matter, but stick with it. So now I'm going to compare big to small, the height of the big height to the small height, the big length to the small length, the ratio of the big width to the small width. Substitute the numbers. I know the height is 20 inch over 8 inch and 11 over the L, which I don't know the length of the small prism, and 8 inch over W, I don't know the width of the small prism. My advice is to take both ratios separately. So let's find only the length at this time. Bring the 20 over 8 equal the 11 over L. Now to find the missing proportion, you cross multiply. 11 times 8 is 88 and 20 times L is 20L. Now solve for L by dividing both sides with 20. You end up with 4.4 inch, which is the length. Now let's take the other ratios, which is 20 inch to 8 inch equals 8 inch to the W. So now we're finding the width. Again, to find the missing number in a proportion, you cross multiply. 8 times 8 is 64 and 20 times W is 20W. Now solve for W by dividing both sides with 20. You end up with the width of 3.2 for the small prism. For today's lesson, we will find the volume of similar figures. For you to understand that, let's follow this table. What happens to the volume of a solid if you double, triple, or quadruple the dimension? For example, here's two cylinders, and we all know how to find the volume of a cylinder. pi r squared times the height. We are trying to find the volume of the original cylinder. And then what happens if you double the dimension, triple the dimensions, or quadruple the dimension? So each dimension needs to be multiplied with a scale factor. If you double, the scale factor is 2. If you triple, a scale factor of 3. If you quadruple, the scale factor is 4. Now, the original cylinder with a radius of 1 and a height of 1, the volume would be 1 pi. So I'm keeping pi with the volume. But if I double the dimension, that means the radius is 2 and the height is 2 because the scale factor is 2. So the volume will be 8 pi. If you triple the dimension, that means the radius is 3 and the height will be 3. So the volume would be 27 pi. If you quadruple the dimension, then the radius is 4, the height is 4, so the volume is 64 pi. Now let's find the relationship between the scale factor and the volume every time you double, triple, quadruple, or any other scale factor. We always go back to the original volume. So what happens to the volume when you doubled or used the scale factor of 2? The volume went from 1 pi to 8 pi. That means it's 8 times bigger because you divided 8 divided by 1, which is 8. So it's 8 times bigger. Since the scale factor is 2, how did I get 8 times bigger? Because 2 cubed equals 8. So the scale factor is cubed. That's how many times bigger the volume will be. Now, what if you triple the dimension? That means the scale factor of 3. How many times bigger from the original? It's 27 times bigger. Since the scale factor is 3 and I cube the scale factor, 3 cubed gives you 27 times bigger. What if you quadruple the dimension? That means the scale factor is 4. The volume is 64 times bigger than the original. So if the scale factor is 4 and you cube the scale factor, 4 cubed equals 64 times bigger. Now, how can you find the volume of similar figures? Here's the small blue cylinder. I'm giving you the dimensions. The radius is 1 and the height is 2. To find the volume, you multiply pi times the radius squared times the height. It gives you 6.28 inch cubed. Now, how can I find the volume of this cylinder? And I don't have the dimension for it except for the height, which is 4 inches. How can you find the volume without knowing what the radius is? One way is to use the scale factor. To find the scale factor, it's the ratio of the side length. So since I know the big cylinder, which is the red cylinder, is 4 for the height, and the length of the original cylinder is 2 inches for the height, divide those two, gives you the scale factor. 4 divided by 2 equals 2. So I know it doubled, right? So the scale factor equals 2. So the new volume equals the original volume times the scale factor cubed, because that's how many times bigger the new volume will be. So the original volume is 6.28 multiplied by the scale factor, which is 2, but you need to cube it. First of all, cube 2, which means 2 times 2 times 2, which is 8. Then multiply it by 6.28, gives you the new volume, which is 50.24 inch cubed. So this time we use the scale factor. Find the scale factor, cube it. That's how many times bigger the new volume is. And if it's the scale factor is a fraction or less than 1, then that's how many times smaller the new figure would be. Find the volume of similar figures. I want to find the volume of the blue pyramid. I know the side length for this one is 3, the other one is 4. I know the volume for only the red pyramid, but not the blue one. Without having all the dimensions, I can't just find the volume of the blue figure. That's why we use the volume of similar figures. Another way, other than the scale factor, to find the volume of a new figure, of similar figures, is this equation. The ratio of the volumes of similar figures equals the ratio of corresponding side length cubed, because the scale factor is cubed. So now set up your ratio, and I will set up my ratio of the red pyramid over the blue pyramid. The volume of the red pyramid divided by the volume of the blue pyramid, that's how the ratio goes, equals the side of the red pyramid divided by the side of the blue pyramid, but make sure this whole fraction is cubed. Now substitute the numbers. The volume of the red figure is 9. The volume of the blue figure, I don't know what it is, so I'm going to name it V, equals the side of the red pyramid is 3, and the corresponding side is 4. But make sure it's cubed. Now cube the fraction, which is the ratio of the side lengths. 3 times 3 times 3 is 27, and 4 times 4 times 4 is 64. So you end up with 27 over 64. Bring the 9 over V down. Now to find the missing value of a proportion, you cross multiply. 27 times V is 27V, and equal 9 times 64 is 576. Now I need to isolate V by itself, which is the volume of the blue figure, by dividing both sides with 27. 27 divided by 27 cancels each other, so the volume equals 576 divided by 27 is 21.3 inch cubed, and that is the volume of the blue figure. How about finding the surface area of similar figures? The two spheres are similar. Find the surface area of the red solid. Round your answer to the nearest tenth. This time, I will show you what the relationship between the corresponding side length and the ratio surface area of similar figures. So the ratio of surface area of similar figures, and we use SA for surface area, equals the ratio of corresponding side length, this time squared, because the areas are always squared. So let's set up the ratio, and this time I will set up the ratio red to blue. So the surface area of the red sphere divided by the surface area of the blue sphere equals the radius of the red sphere divided by the radius of the blue sphere, but this time the ratio is squared. Substitute the numbers. I don't know the surface area for the red sphere, but I know the surface area for the blue sphere, which is 5027, equals the radius of the red sphere is 15, the radius of the blue sphere is 20, but this time I need to square the ratio of the corresponding side lengths. Square the fractions first, which means 15 times 15 is 225, and 20 times 20 is 400. Bring the equal sign and the other fraction down. Now, to find the missing value of a proportion, you cross multiply. So cross multiply, surface area times 400 is 400 SA, equals 225 times 5027, which is 1,131,75. Now isolate the surface area by dividing both sides by 400, because I need the surface area by itself. So divide both sides by 400. 400 divided by 400, they cancel each other. You bring the surface area down, equals, divide those two numbers, you get 2,827.68. But I need to round it to the nearest 10th place, and the 6 is in the 10th place. Now, does the 6 stays the same, or does it go up 1? It all depends on the 100th place. Since it's 8, then the 6 goes up once. And that would be the surface area of the blue sphere. So in conclusion for today's lesson, to find the volume of similar figures, remember to set up your ratio and stick with it. The volume of a solid A divided by the volume of the solid B equals the side A divided by the side B, which is the ratio of the corresponding side length, but cubed, because the volume always cubed. Or the new volume equals the original volume times the scale factor cubed. So cube the scale factor, then multiply it by the original volume, will give you the new volume. Those two different ways to find the volume of similar figures. What about the surface area? To find the surface area of similar solids, Again, set up your ratio and stick with it. The ratio of the surface area of solid A divided by the surface area of solid B equals the side A divided by the corresponding side B, but this time the ratio is squared because area always squared. Keep that in mind. That's it for today's lesson. Thank you so much for liking, commenting, and subscribing to my channel. Have a great day and see you next time.